Topic A, functions and function types. So let's start talking about functions. So functions are an easy way to group together a number of lines of code that have, universal functionality and that we want to reuse. So it's primarily a mode for reusing useful code whereby we, by one line, call a function as opposed to doing 5, 6, 10, 15 lines of code again and again. They can also be thought of as mini programs within a bigger program. Realistically, everything that you can do in a file, you can also do within a function. Now, functions also have the capacity to have parameters or arguments. Essentially, you can think of those as inputs, as well as an ability to return an output. Now, you can do a function without an output, without any inputs. However, functions have the capacity to have that. So functions have a capacity to take in information with multiple variables or multiple sorts of values that go into a function and then return a single value or, well, a single data type. They could return a tuple, for example. So what else do we have? Functions ideally perform a single task. So like I already said, there is no limitation on how much code you can put into a function, and there's no limitation on what a function can do. But ideally, you want to group your code in such a way that, individual functions do one single, easy to define task that you can define in a comment, perhaps in 1 or 2 lines. So there are 3 main types of functions. The first one you're going to be very familiar with. These are the built-in functions. We've used a great many of them, like print, min, max. Those are built-in functions. We've also got user-defined functions, and user-defined functions are functions we create ourselves. So essentially, when I was talking about here, or for the most part, user-defined functions. Finally, we have anonymous functions, which we are going to get to. It's a sort of very unique feature of Python, which don't amount to much more than a real shortcut to writing a normal function. So let's start with built-in functions. So built-in functions, well, you create them and you can use them pretty much anywhere in your code, and you can reference them even from other Python files. So like I said, we've been using these. Here are 3 examples that we've used. We've used input to get a user input and save that as a string. We've used print to print out various statements, variables, and so on. So you got also like a min, max, which minimum returns the smallest item in an interval, maximum returns the biggest. Off the top of my head, we've done a number of string functions or string methods like .upper, .lower. We've done append on list. So this is something that we've been using for a long time, and now you have the ability to sort of categorize it in the bigger picture of Python and know where these guys fit. So this is a simple demonstration of a built-in function, print hello world. So let's look about user-defined functions, which are essentially the main thing we're going to be learning skill-wise in this lesson. So user-defined functions are functions that the user writes to achieve a specific goal. Remember, ideally you want them to do one specific task. And they look a bit like this. So you have, first of all, a function name. The idea is that this is descriptive. So, like let's say if you're calculating a surface area, you'd want to be as specific as possible. Like if there's a formula in there, you'd be surface area square or cube or some specific object. And in here, in the brackets go parameters. Remember, we can have that as blank, or you can take 3, 5, as many parameters as you need. In here, indented right there, is going to be the logic. Now, at the very end, this will be the last line of your function, unless it's inside like a control statement. You're going to have a return. So the option to return a value. You do not have to have a return statement in a function. So to define a function, we need to do the following. 1, use the def keyword, followed by the function name. Def function name. We need to add parameters if we want to use any. If not, empty brackets. and then write the logic of the function. Obviously, if there is nothing in a function, it won't, not only will it do nothing, it'll cause a syntax error, unless you put the pass statement. And finally, use the return keyword if you want that function to return something. So, just to recap, a user-defined function must have a name. It is best practice to have that name very descriptive of the task. Here's one more example. For a function that calculates monthly average rainfall from a list of values, you can call that function calculate monthly average rainfall rather than calculate. This would be the syntax for that. So the function would take in one variable, one parameter, one input. That would be a list. Indented here would be the function, and then it would return some value. So very important is that once functions are created, they need to be called. Imagine a function is like blueprints to build a building. Well, the purpose of a function is to build a building, but the actual code in the function doesn't do anything. It's a set of instructions that need to be executed. So here's an example. So this function is pretty much as simple as you can think of. It takes in a parameter, which is name. It'll take a string, and then it prints a greeting. When we say greet Bob, it'll say hello Bob. So this code here, these two lines don't actually do anything. It's only when the function is called that something happens. Here is another example, a more advanced greeting function. So this function takes two parameters, name and gender. So if the gender is female, it will print out hello miss, and if the gender is male, it'll print out hello mister. Again, nothing happens unless the function is called, and it's called in that line. All right, here we go. Time to write some functions. And I really want to build up in this video very, very slowly. I'm going to start with a function that basically takes no parameters, returns no value, just prints something, and then to one that takes in parameters, and then one that takes parameters and returns values. And then we're also going to look at docstrings and functions. So let's start with the simplest thing that I could think of, which would be a function that just prints something. So we can say def function, I'm going to call this hello10. And hello10 just print hello times 10. Maybe we'll add a space. Maybe that's a nicer. And guess what? I mean, if I run this, nothing happens. I actually have to call the function hello. So right now, that is going to get executed because of the function call. So if you're going to see 10 hellos. Okay, next, let's do something a bit more interesting. I'm going to create a function that draws a pyramid. I'll call it def pyramid. Now, this will take in a parameter called layers, but just for starters, let's do it without layers. We can go for I in range 0, 10. And I can actually write a symbol, and then I multiply it by I, and then I center it. So let's make a symbol. Let's make a variable called star. Yeah, hashtag would be right. So then we can print star.center, and center has two parameters. One is the width. So the width, I don't know, I can make 10, and the other one is the symbol that I want to center within, and that symbol is going to be a space. So star.center, and we can also, am I missing something? I'm missing a closed bracket, and then I can actually say star plus equals to one more. I mean, we've got a hashtag, not a star, but this should do it. So obviously if I play this, nothing's going to happen. I have to call my pyramid and watch what happens. So it's kind of not a perfect pyramid. So let's do a couple improvements. So instead of centering 1 to 2, we can actually add 2 stars in each. So it'll be 1 to 3. So that it's going to add like that. So run that. Okay, that's a good start. See this width here? This width should actually be twice that. So that should be 20. And there we go. We have that pyramid. So let's now control for how many layers that pyramid has. Let's add a parameter. So instead of 10 here, I'm going to create a variable called layers. And layers is going to be a parameter of the function. Layers. So star can go from 0 to however many layers, and it's going to get centered. Not on 20. Remember, that's going to be layers times 2. So if everything works, and it doesn't, I must have misspelled layers at some point. For I in range, I didn't put 10 in there. All right, so that should, yes. So you can also make a smaller pyramid, 5, make a larger one. So as you can see, it's very, very easy to convert something from, a single function, a single shape, it just does 10-layer pyramid, to basically replace that with this variable here, layers, which is a parameter of the function, and then this is a universal little pyramid rower. Okay, so right now we've gone from a function with no parameters to a function with a parameter. Next, let's do something that returns a value. So I'm a fan of geometry, so let's do something very basic. Let's do the area of a circle. So circle area. And all we need for that is a radius, because the equation for that is pi r squared. So we can literally return, well, pi times radius squared, but we don't have pi. So we can import math, and we can return math.pi, which is 3 point, it's just like a more detailed, I don't know how many decimal places, probably like 10 times radius squared. Let's try calling that circle area. If we put 10 in there, you're kind of going to see how many decimal points that has. And now we're learning a lesson. Even though I called this, even though there was no error, you're noticing nothing is printing. When you return a value, that doesn't mean that you print it. So you could print circle area, and then you're going to get, that output. So that's about 10 decimal places. And obviously you can do any radius and calculate the area. Now instead of this return statement, you can do a nice printed statement saying the circle, area of a circle with radius 10 is such and such. But then you cannot really use this inside another calculation. So this is more useful as a tool, even though it doesn't, print anything out in a nicely formatted way. So we've gone from no parameters to parameters to parameters and returning values. Let's do a more advanced maths one, and let's do a function with a docstring. Now, docstrings are important in larger projects with a larger code base, and especially if you're writing lots of functions and other people are going to be using your code. It is best practice to actually write 1 or 2 lines that describe what the function does. Not how the function does it, but what the function does. And there's a couple of best practices here. As I said, there's going to be those triple quotation marks. You have to start with a capital letter and with a full stop. Nothing bad happens if you miss those out, but those are just the conventions. So let's get a cuboid, like a surface area of a cuboid. So that's what we're going to calculate. Surface area cuboid. Now, a cuboid is just like a cube with an even side. So 3 sides, but it's a cube. So we can have 3 parameters, length, width, height. So here's where you put the docstring. You do triple quotation marks. And you'll notice something when I start typing. This function takes in length, width, and height of a cuboid and turns the surface area. So I think I need a space there. You'll notice that docstring here, this is sort of a darker one and it's not highlighted. So basically this italic font here and a slightly brighter font kind of tells you that you're dealing with some special function of Python. So we're going to print this out in a minute, but we actually need to write the function. So this is just documentation that other people can view. And here is where we need to figure out how to do surface area of a cuboid. So you have 3 sides, return. So there are 3 sides, and this is what they add up. Length times width. So essentially there's 6 sides, but there's 2 of each one of these. Length times width, width times height, and length times height. So each one of these is multiplied by 2. So I can just put 2 multiplying all of this. And that really should do it. That really should do it. So let's test it out. My function names, since they really should describe what this does. And I mean, if your function is, so descriptive, really puts into question why do you need a docstring. But, 3, 5, 7. I'd be remiss not to teach you docstrings. So let's run this, and I'm not printing it yet again. So print 142. So that makes sense. And now for the docstring. So all you need to do is actually get the function name and put doc. Dot underscore doc. And what this is going to do is just print out. This function takes in line. So let's say you had hundreds of functions and then one of them was used and you don't know where it came from. You'd be able to just print out the doc string of that function, get all the information from it. All right, I think that's enough for these basic function examples.